Welcome. My name is Ustyianovych, and today I plan to present our with Professor Denilson Barbosa piece of research with the following topic: instant messaging platforms, news multitask classification for attitude, sentiment, and discrimination detection. Our study focuses on the analysis and processing of text data related to the Russian war in Ukraine, and our goal is to improve the efficiency of distinguishing between stance attitude of a given message and determine its sentiment. It's important, first of all, from cyber hygiene perspective as well as cognitive security. Also, our piece of research is a valuable contribution to the Ukrainian NLP capabilities. On this slide, you can see the related works that were quite significant to our study, and they focus on the following areas, like association between geopolitical events and dynamics of online activity, data sets related to the Russian war in Ukraine from social media, web forums, and that occur during online communication, minimization of antagonistic behavior on social networks, and applications of text preprocessing in order to improve and enrich Ukrainian NLP. Our piece of research is unique because of the following. We use Telegram communication platform, which has its own communication style, various audience, and the format in which information is shared, the limitations and possibilities are also quite different from other social platforms, networks, forums, and so on and so forth. We develop a multitask model based on large language model transformers to classify at once three different variables, which we're going to talk more in next slides. And we also address the problem of scarcity of publicly available labeled data related to the current war between Russia and Ukraine. Here you can see about specifics of the dataset collection for our research. We thoroughly selected pro-Russian and pro-Ukrainian channels based on so-called black and white list provided by trustworthy government institutions and organizations. At this moment, we still continue data collection and enhance our processing processes and capabilities. Here you can see some statistics on our data set. As you can observe, there is a quite good balance between the sources, so 55% for pro-Russian and 44% for pro-Ukrainian. Also, we managed to have a good balance in language, which initially wasn't available. The mean and median token count after text preprocessing is 29.5 and 21 respectively. We figured out that token count can significantly differ based on the communication style of a given channel. If it's a blocked one, then it usually tends to be higher. If it's just news or quick notes on a given topic, then the number of tokens is lower. As we figured out, majority of messages exhibit a negative sentiment because of the nature of the events we collected and analyzed. We applied AI agent to perform sentiment classification and dataset labeling overall. We shall mention that the results are quite good. However, GPT 3.5 struggled with interpreting such complex topics as war and military conflicts. Therefore, GPT 3.5 is not the best fit solution for sentiment classification in a given case. Nevertheless, it still managed to identify sentiment of the majority of the messages quite well. And on the figure on the right, you can see how it fluctuated over the course of time. So during our research, we faced the following challenges. First of all, quite regular drifts, data drifts, model concept drifts, because they depend on the dynamic of events in the real world. Also, there was quite scarcity of labeled data. That's why we applied AI-based agent in order to automate this. Another challenge was to validate these labels and make sure they are accurate enough, and excluding of irrelevant messages that might be advertisements or information that is not related to the war at all. And the main limitation are specific messages with a given stance not available in particular language. Like in our case, there are little pro-Russian, there were little amount of pro-Russian messages written in Ukrainian language. Also, we deal with the low resource NLP capabilities of the Ukrainian language compared to English. On this slide, you can see our data processing workflow. Everything started with data collection. Then we passed this data to a spacing model in order to clean it, tokenize, and lemmatize. We applied fast text word embeddings, our custom trained model, and XGBoost classifier in order to ensure the dataset has some predictive capabilities. Once we ensure the data is fine to move to the next stage, we labeled it using an AI-based agent, in our case, the GPT 3.5 Turbo model, with using zero-shot classification. Then our labels were validated in a systematic way, and we fine-tuned a language model. Afterwards, we ensured the performance metrics meet our thresholds and performed some test inference so that we can see what the output looks like. From text classification perspective, our goal was to have a multitask model that can distinguish between pro-Russian or pro-Ukrainian stance, or even a neutral one, determines the sentiment and presence of discrimination. As it was mentioned, fastText and XGBoost classifiers allowed us to validate the predictive capabilities and predict the originating channel attitude, where you obtained a O92 AUC score. Then we fine-tuned a MT5-based language model, which accomplished the multitask goal of our research. We restricted the number of tokens to 256, and the training process spent 10 epochs with batch size of 64 for both training and evaluation. The multitask model displayed an above mediocre performance with average accuracy of 74%. As we figured out, the highest accuracy, about 94%, were for the originating channel attitude and geopolitical stance. Also, the presence of discrimination was detected quite accurate as well. However, because of this balance in this particular variable, we cannot be sure the results are actually valid. For sentiment, there is still space for improvement, and we are not satisfied with our results. So, in the conclusion, I would like to mention that in this piece of research, we introduced a TRWU dataset consisting of text data from diverse Telegram channels on the Russian aggression against Ukraine. We managed to build a data processing pipeline, evaluate predictive capabilities of the data we collected, perform labeling using zero-shot classification, and validate the labels, and at the end to fine-tune a multitask classification model. As I've mentioned, it still worth to advance stance sentiment classification with accurate and highly strong labels. It might be worth to apply context-based sentiment analysis because a given message may contain multiple or mixed sentiments for specific entities, and it's still worth it to pursue higher accuracy for the multitask model. Thank you for your attention.